Hello, dear students. I am Samir Velankar and I welcome all of you to this another video on concurrency control and transaction management in DBMS. In the previous video, we were seeing about the problems that concurrency control. That means what are the problems that can occur when multiple transactions are executed simultaneously in the interleaved fashion. So we continue that. In the previous video, we saw lost update problem or write-write conflict. In this video, we will see dirty read problem. Interesting term here, dirty read problem, which is write read or read write problem, whatever you say, read write or write read. So, what is the problem all about? Now, to understand this, just observe it is very easy to find out whether the two transactions which are running concurrently are going to result in read write or write read. You can check that transaction T1 is having a write operation on A, after which it preempts, giving a chance for T2 to execute. And after this write A operation, immediately transaction T2 is reading the same data item A. So the dirty read problem occurs if two transactions T1 and T2 running simultaneously have write followed by read operation on the same data item. Same data item is very important. So let's see what are the consequences, what really happens, why we would not like this dirty read problem to occur and what the problem is exactly. So as an example, let's take the data store again. And let's say that A is, let's say, 30,000 and B is, let's say, 20,000. This is the permanent storage. And as usual, T1 is transferring 10,000 from A to B and T2 is offering 10% interest to A. Now T1 starts first, and you know that as this is the first request for reading A, there is a separate buffer allotted for both the transactions, and in this buffer, A read will be 30,000. And then who was asking for A? Of course, T1 was asking for A. So T1 gets the value of A from the main buffer, and the value of A is 30,000 in the local buffer of T1. The next line executes, which makes A equal to 20,000, reducing the balance by 10,000, and then write A occurs. Now, write A, remember, doesn't mean that we are writing this value of A 20,000 in permanent storage. We are actually updating the value of A in the buffer allocated for both transactions. So here A becomes 20,000. I hope you are understanding. What happens after that is that T1 preempts, giving a chance for T2 to execute. And T2 is now reading the value of A. Of course, T2 will read from the buffer, which is allotted for both transactions. So here A read won't be 30,000 from the DB store, but it will be 20,000 because that's what it looks on in the local buffer in the buffer. So now T2 is having the value of A as 20,000. The next line gives 10% interest. So A will be 22,000. And finally, it even writes the value of A. Remember, this write operation won't write the value in the permanent storage, but it will update the value of A in the buffer allocated for both transactions. So this value is now going to be 22,000. And after that, this T2 preempts. Now comes the fun part. Just check, what if T1 now resumes and due to some reason, just check, T1 is now resuming from read B and due to some reason it fails. This transaction fails. Due to any reason, maybe power failure, maybe bad sectors in the hard disk, maybe hard disk failure. But this transaction fails. In that case, transaction manager or management system will roll back this entire transaction because come on, the transaction has not finished. So whatever changes that were made by this transaction should be rolled back, isn't it? And what do you mean by rollback? Rollback means this transaction will start all over again. Yes, it is not that it will be rolled back and it will be forgot. Basically, the transaction T1 is rolled back and it is rerun. It executes again. But then rollback means it now will take the value of A as 30,000 from the store, from the data store. It will recall its first value that it took when it started last time before failing. Now it has A equal to 30,000 and it now runs. Just check. When it runs, it makes A equal to 20,000. It writes the value of A. So A now is 20,000, isn't it so? And then it continues to transfer the amount in B. But the problem is that whatever has happened with this transaction here, this transaction is lost. Basically, what if there was this transaction has got completed, as you see, then this transaction has actually read a very very bad value, because now whatever 22,000 it has written has been lost. I hope you understood that because this T1 failed, it was rolled back, and as if nothing happened over here, as if nothing happened, A rolled back to 30,000. So the read, there we come to the point. This read, which T2 did last time, was dirty read. Let's understand the word dirty now. Why it is known as dirty is because the concept is like this. You will like it. The concept is that this transaction has written some value in the buffer. Let's not take some particular value, but it has written some value in the buffer. But this transaction has not yet committed. There is no commit statement. That means this value, updated value of A, is not written in the permanent store, in the DB store. Okay, there is no commit. Although this transaction has updated the value, but it has not committed yet. And look what T2 does. Poor transaction. What T2 does, it trusts T1. It is trusting T1 and it is reading this updated value and operating on that, and even writing, even updating its value. But what happens if this T1 rolls back somewhere because of failing? Then whatever T2 has read from this buffer, the updated value has become dirty, because T1 is going to forget whatever changes it has done, and it is going to it is going to roll back to the original value, and this read becomes dirty, isn't it? It's like, it's like, let me give an example. It's like, this is your friend T1 and this is you. You are sitting behind your friend in the exam hall, and your friend has written something on the paper, on the answer paper, some answer your friend has written in the answer paper. And not, it should not be like that in real life, but just as an example, you imagine that you are copying from your friend. So whatever your friend has written on the answer sheet, you're copying it. You have read that and you are modifying a bit, but you are writing it on your paper. And what if after some time your friend rolls back and say, oh good lord, some mistake happened, and let me try to write the answer again all over. That's bad. That means whatever you had read last time was dirty, isn't it? And you should not have done that. But what if your friend commits? What that means is that your friend submits the answer paper or that particular supplement to the supervisor. Okay, now you know that whatever you read after this write is surely correct, and you can be sure, 100% sure, that because your friend has submitted the paper, whatever I read after this write is surely correct, and I can trust my friend. But although there was no commit, and before the transaction T1 committed, you have actually copied the value in your buffer. That's dirty read, what I am talking about. Dirty read problem occurs if there is back-to-back write and read operation on the same data item across two transactions. Isn't it so? So basically this is WR conflict, write read conflict, which occurs on the same data item, and the read operation is following the right operation. So we call this as dirty read. Now, don't worry if you have not understood this in and out, because most of the chapter on concurrency control is going to pay attention to this write read problem. I'm not saying that write problem will be neglected, which is lost update problem, but dirty read is the most challenging one, and we will address this problem and how to solve it in the coming videos. Thank you very much.